So, who knows how to write Rust? That's not bad, right? Okay. Who is pretty sure what a microcontroller is? That's also not bad. Let's see whether we can keep that or not. Yeah, so I'm trying to get you into that topic. I'm not an expert. I'm working at Otto. We don't do microcontrollers here, so it's not like I'm doing this every day. I'm just doing that if I have time, and I usually don't have time. So, on the one hand, on the other hand, it's basically not a walkthrough for any project that you will do. It's more like as introduction, but I will get to that in a second. If you wanna find me on any social, usually I have this icon here. So yeah, that's usually how you spot me. So for a quick agenda, I'm doing an introduction now, probably. Then I'm trying to refine what a microcontroller is, especially what the difference is between a microcontroller and other devices. Then, of course, like you might have guessed, microcontrollers are not as well supported as we saw a Mac before. I have an Intel here. So there is some difference, and it's important to know the difference and the effects. Then we will pass over some interfaces, what you might be doing, what might be interesting. And at the end, you hopefully have some kind of guidance how you would approach getting into microcontrollers and getting into Rust. What we will not do in comparison to the previous talk is live coding or anything. And I don't think it makes sense in this session here to kind of start coding Rust for microcontrollers because, I mean, you need some equipment usually. You need microcontrollers. I don't brought any with me, sorry. So the current plan would be in February-ish at the makerspace that I will link here. We will do a session. So if you're interested into getting into Rust, into microcontrollers, just join the group, and we will then probably January at best. We will add an event, and then you can kind of try to get a place. I don't know. Maybe nobody will wants this, so it's easy, or everybody wants this, then we will have another one. But we figured it out. So, who am I? I'm the guy with the mountains here. I'm just a software guy working at backend stuff. I'm a lucky person at Otto, so I don't have to do Java every day. So I'm allowed to do Go every day. So that's pretty good. I've been not most, but half of my professional career done. I did C++ and C, and I did like it quite a bit. A few years ago, I've fallen a bit out of that love, so I'm now pretty much, or I do find Go pretty good. I do like Rust quite a bit. You see here, I also like Python. We do have a lot of our software running on Kubernetes. We do a little bit of machine learning, infrastructures code. You don't know that, and we all do that. And if I'm not occupied with anything computer related, I do woodworking, and that's a good switch between just typing all day. Why will the workshop probably be as soon as February? Because I'm at FOSDEM. So if you wanna meet up, I'm at FOSDEM, and you should too. Yeah, and from the expectation level, really, I mean, Rust is a thing where I dabble every once in a while, but it's not like I'm a pro. So take it everything that I say with a grain of salt, of course. And now let's just get straight in. So microcontroller, right? What you have in these boxes here is a microprocessor, and a microcontroller is smaller. Okay. Um, Also, usually nowadays, if you have a microprocessor, you have multiple chips. Microcontrollers, that's one chip. So that's just everything that's in here. Usually with a microprocessor, you have a bus. So here I have HDMI on that bus, I have USB on that bus, and I have a gazillion other things on that bus. Usually with microcontrollers, there is no bus. Or if you want a bus, you have to kind of add it yourself. But the raw microcontroller usually doesn't have a bus. That also means, I mean, the components usually would use a bus, so you get less components, you get less capabilities. But of course, that also means, hey, it can be smaller. A microcontroller can be smaller. It can be more power efficient. But yeah, you cannot do everything that we take for granted nowadays. So I'm presenting here. That would be a lot of work to get a microcontroller to the point that I could just present mirror boards. So, but, um, now the question is microcontrollers. That was more like the object view. So why is it of interest to me? So I already told you I'm not a fan of C and C++ anymore, right? What I do like though is having my devices running on battery, for example. So the more efficient this is, the whole thing is, I'm pretty happy with that. Um, I'm also not doing this full time. So what I do not want is to figure everything out by myself. I just don't have the time, quite frankly. So I really want to have a solution that other people already successfully implemented. I'm totally okay with fixing one or two things, but I'm not fixing everything. And yeah, and I'm violating that at times, but this is not the story. I do. The people that come to my home usually see a lot of wiring, so I love Ethernet, for example. Um, but I can't wire everything. I mean, there's only so much space I can lay a cable in. So Wi-Fi matters. So I really want to have something that I can control over my network and not have a cable attached to it. Like I said, efficiency is somewhere where I'm big at, and I really like for my devices to boot. I mean, it's kind of okay to have a few seconds for the big devices, but if a small device takes more than 3 seconds to boot up, there's something wrong in my opinion. And I'm okay with doing microcontrollers, but I really do not want to do SMD soldering. I mean, I have big hands, and I tried it, and no, it's not for me. So everything which is kind of more more not as delicate. Let's put it that way. That's fine, but not SMDs, or even lower. That's not working for me. So that's my story. And now, if we come to the microcontrollers, does anybody know what an ASP 8266 is? And would you agree it's very cheap? True. I would think so. So that's the one of the great I mean, maybe even the best thing about it is it's really cheap. You can buy a gazillion of these, and you don't spend a lot of money. It's a few euros, and then that's it. So usually you buy them in bulk or have them big packs at home, and it doesn't matter. It's just a cheap microcontroller. So that's for me, one of the first, at least, microcontrollers that I got into contact with and already kind of did a lot of stuff with it, so programmed it a little bit and sold it a little bit. And why this chip is important, I can't spoil now, but we'll get to that later on. For completeness sake, I mean, this is an extensor RISC processor. I mean, we can geek out over processor architectures and stuff later on, but I mean, that's just, it's a processor. I mean, one type of processor. Extensor is the instruction code, basically. And it's just different from, let's say, AMD or ARM. And like, it's so cheap. People have used this for gazillion years. That's at least my feeling. So it's really battle tested. And if you go at GitHub, there's a lot of content that you can use and can mostly see, I think, and can use to get your project started, for example. It only has a single core, but that's probably maybe okay for you. So it's not a big microcontroller, but it's for a lot of scenarios it might be okay. And why was it kind of interesting is that there is it's the grandfather, if you will, to the current generation. So currently, what the ESPs, what they would kind of be replacing that with would be the ESP32C3. And that's not as cheap. So you buy, you pay more for that. The good thing is that it's pin compatible. So most of the C code, for example, that you find online will be pretty compatible with the old one. So there are all these solutions already in the wild that you can use with this new chip. You also see this one already has USB-C, at least in some variants. So you don't even have to do an adapter switch or whatever. So you can use it pretty straightforward with your laptop if you want. And that's also the newer generation in general is the ESP32. And here the C3 is a certain variant. Here I have links to all them, and there are different variants. The one surprising thing is probably that they are not running all the same instruction set. So the C and H, for example, are RISC-V microcontrollers, and the S is an extensor. And I mean, you probably remember that this one was extensor 2. So they are kind of different. And that's also where kind of it begins that you really, if you want to do microcontrollers, you really need to know what your hardware is. It's not like I buy my Intel machine and it has the standard peripherals and standard bus and everything's fine, but you really, really have to read through documentation, really have to kind of get into, hey, what's the instruction set? Which kind of tooling do I need? It gets just a lot more complicated than just doing, just programming what we, or at least I normally do. And from the capability side, it goes from not so much to a lot. So here you do have Wi-Fi, but you have very few pins. You have very few things that you can communicate with. And the further down you get, the more specialized pins and built-in extensions you get, basically. Like I said before, you do not simply choose a microcontroller. I mean, you basically really have to go the other way around. You have to first really think about, okay, what do I want to achieve? And then you can kind of narrow down which parts or which microcontrollers are even in the picture, depending on your what you want to do, because there's a lot of combinations, and also personally, I don't find a lot of the official documentation very well structured. So at times you really have to go pretty deep into the documentation until you find, oh no, that's not working because there is a shortcoming X, Y, Z. So that's at times it's a little bit annoying. But I mean, if you really want to, you can do that, and but it's a little bit consuming. And here, I mean, I'm kind of biased, and I get to why I'm biased in a second. And I told you about the ESPs, but I mean the Raspberry people. I mean, who doesn't have 5 Raspberries laying around somewhere? There's also the Raspberry microcontroller. There is the SDMs, there's Atmegas, and these are kind of the usual suspects, if you will. I know we already talked not explicitly about it, but the reason why I'm talking about the ESPs is, of course, because it's compatible with Rust. The same is true for the RPs. STM, I think, I have a link in here. So they also have some compatibility with Rust. At Mega, I'm not so sure. I think I found something, but I don't really know in what kind of quality it is. And probably there's, I don't know, hundreds of microcontrollers probably missing. But that's at least the usual suspects that I know, and they're all getting more and more supported by Rust tooling. If you follow my scenario, you would use the ESPs, of course. So for the ESPs, the state of Rust is as follows. So we already looked into which kind of type of microcontrollers these are. For recap, and for example, the ESP32C are the RISC-Vs, and RISC-Vs are officially supported in Nightly. So that was half a year ago. I have not checked again whether this is kind of stable again. I don't know. But that's in the official tool chain. If you are going with the S models, for example, then you have an extensor. Extensor should be landing or has actually landed in LLVM already, but it has not made all the parts yet into the official Rust support. So you still need to install separate tool chaining to kind of cross compile to the extensor models, the S models. Also, if you really want to go back, or if you would really want to go back, there is no support for the ESP8266. That's not to say that some people are not trying to do it, but I wouldn't kind of keep my hopes up. I mean, people are working on a hardware extraction, for example, but I mean, this microcontroller is so weak that you really the question really is how much you can do with it anyway, because there's barely anything there. So I don't know. You can try it, but I personally would rather rather buy an EU chip and get it over with, because yeah, I don't know when support would even be finished. On the other hand, what I neglected to say, I think, is that the ESP8266 is deprecated officially, so they will not make new ones. So the new ones are really what's officially supported. in today's world, somebody will probably try to get Rust running on that thing. I don't know how many years this will take, and how stable it will be actually. So far, also, I do have one S at home, and I have not done anything with that really. I've always been kind of lazy, and the risk Vs were good enough. So I never got over the bump of installing the toolkit and everything. So I'm personally quite okay with the risk V, but it depends on what you want to do. So now the question is, and now we get into the interesting stuff. So if you have the ESP32, for example, then you don't have it because it's pleasing to the eye. Usually what you want to do is you want to program it. I mean, that's what we're here for, I think. And who knows what STD versus no STD is? Okay. So for the people who don't know, STD is the standard library, like the name suggests, I think. And the standard library has a lot. And if you hear kind of subtract the standard library, there's not much what's left. I mean, yeah, you can program with that, but what you can do is pretty limited. So, but of course, that's kind of a deliberate choice. I mean, if you have the STD, there's a lot of software and at times an operating system what needs to be present, versus if you have no STD, you don't need anything. You just need to execute the code, and that's everything that you need to get your program started. And that's also a huge problem with Rust, I think, because the I mean, in my opinion, it was always pretty straightforward, because if you did C or C++, you were always kind of content with, hey, there is not a lot of library support. Hey, you can't do that. Hey, there's no support for this. And everybody was kind of happy. With Rust, you nowadays have so much possibility. You can do web development. You can do this. You can do WASM. It supports everything basically. But it also means you're kind of spoiled because you want to do all that. But on the other hand, if you go into the low level part, then it also means no, your operating system maybe would not even allow to do that. And that's the point. If you do microcontrollers and you do not have an operating system which supports part of the STD crate, for example, that basically means you cannot use all the shiny basic tool that we have. I'm not even talking about the layers on top, so all the nice libraries we have nowadays. I'm just using the standard library where the most crates, I think, depend upon. But let's say you just have your ISP and you want to get started. So you can get started with both, and I really am quite surprised how good the documentation is there. So it doesn't really matter which route you go, the documentation is really good. If you want to get started with that, I've linked the books here, the book here, and you can just start. And the book will really take you through that. It's well written. There's most of what you will have to know, and that's all fine. Caveat is you should kind of, I think about what you want to do. There's this thing, ESP Home, where a lot of the stuff that you might want to do with your microcontroller might already be kind of scriptable. So for ESP Home, you have a YAML, for example, and you just configure, hey, I want to read this sensor and write it to the ESP Home supported backend or whatever. And the question really is, I mean, I do like writing Rust code, but is it necessary? So there may be a variant where you just want to read a sensor and you don't need to do all the complete Rust dance, but you can just go the ESP Home route and kind of make your first experiments with microcontrollers this way. Maybe that's easier, just for completeness sake. If you still want to program Rust, then we're still left with these two options. And now you have to choose. Well, with every other microcontrollers, you have to choose as far as I know. And the good thing with ESP32 is they support both. And that's, to my knowledge, really a feature that no other microcontroller yet does. So what they do is they basically, do you have it written here? No, so sorry. So they provide all tooling. They provide a free RTOS runs on that. So they have an operating system and they support threading and whatnot. So you can just use your microcontroller like every other device, basically, and just write your Rust code, use your libraries, and be happy. And that's, I mean, a biggie for a software guy who doesn't do that every day. That's a big feature for me. So if you go the standard edition route, then that basically means most libraries should work. I mean, of course, you will get into problems like RAM. Microcontrollers do not have that much RAM. They do not have that many CPUs and whatnot. So yeah, you need to be kind of careful there. But the libraries itself, they should work. Unless you interact with C. So all the sys libraries and whatnot, it's a fucking nightmare. So you can do that, and I wish you all the best of luck. So I tried that with a few of them, and it's really a pain in the ass because with all the cargo tooling and all that, you kind of forget how difficult it is to interact with the system. And for everybody who has done years and years of C++ and C headers and trying to get everything in the right path with the right defines and whatnot, and you will get there again. And getting kind of the search path, defines, cross compilers just right is just a nightmare. You can do it. I nowadays I'm not so fond of that anymore. So I don't know. I really try to just use stuff that is pure Rust, or at least they have already figured out the headers for the ESPs, and I don't need to worry about that. No STD is really the black hole of anything. I mean, yeah, you can do that, but everything STD will not work. So you can kind of try to filter your crates and see how many require STDs. Usually it's 90 something percent something. And you then need to look for, okay, what are explicit no STD libraries out there which kind of work. Usually they also have dependencies, so you kind of need to search for the transitive dependencies that work with your microcontroller, and you have the same problem basically. So if as soon as you interact with C, then you need to find all the headers and all the stuff, and it's just horrible. it is possible to do both STD and OSTD. But I mean, you kind of, I mean, you do you make yourself the. It depends on how complicated you want to make your life. If you have some grandeur ambition, then probably it will be more problematic than if you are kind of content with sending some data into Wi-Fi. That's probably the easier route. If you want to really do crazy stuff, then or normal stuff for desktop, for example, then it might get painful. You will figure it out if you invest probably enough time in there, but just be warned that it might be painful. We already before saw Tok you mentioned. I mean, everybody knows there's async and stuff. If you hear about Embassy is basically the async await, but in the embedded space. And they're getting there. They usually, if you read about the progress, they're doing, they have great progress. I personally do not really know why I would use them, quite frankly, because the whole point for me why you would use an embedded device is, or usually, you have so little RAM and so little CPU that I really do not want anything which runs in parallel and where I do not have control over when it runs and how much CPU I need and everything. That sounds to me a little bit, I don't know, not for me. But I mean, if that's for you, then async await you can do in embedded too, or at least soonish. It's not totally there, but it's quite good. Back what I already talked about. If you use the STD route, you are implicitly interacting with IDF. IDF is what Express calls the IoT development framework. Basically, that's a collection of all components that they need to get the standard library running and more. And it's also kind of connecting to components, getting LEDs to work and other stuff. It also means that they are booting not your code, but OS first, and the OS does some handling that you need for the SD crate. But I mean, all that means that STD, which uses IDF, gives you more functions at the cost of more overhead. So, I mean, you need to kind of decide whether this is okay for you. If you have, for example, a ESP32H model, then this has quite a bit of RAM, quite a bit of CPU, so it might be fine. Also, I tried this with a C model, and it's also fine-ish to the point where you break the stack or something. But it's kind of, you can use that, and it might for the people who come from normal desktop or backend programming, that might be the easiest transition into embedded, probably. That's also the SDKs. I have a link here. You can look into all the gazillion different components and all the SDKs that the IDF provides you. It's a pretty good list, and it's I personally find it really impressive what they are doing, especially on also such a small device, and a lot of that is supported on Rust. I mean, if you get the list of IDF features, I would guess 50% of it is supported in Rust, and they are making really great progress. So I think that's pretty fine. So I mean, I gave you now the basic where you would start with. I mean, if you want to step the step guide, basically, I mean, you usually would not really buy a microcontroller itself, but you would buy what's called a dev kit. That's basically a microcontroller with some specific stuff soldered to. So usually, or the good dev kits do have support for plugging it directly via USB into your computer. That's pretty easy, or makes development a lot easier. Yeah, but I mean, like I said, you really have to kind of read into that. Or, and that would be my recommendation, I would kind of recommend talking just to guys who do or have done embedded programming before. I think that's probably less time consuming than trying to figure out that yourself. I did that, and it is quite a bit of reading. Let's put it that way. Yeah, so buying a dev kit, you can do that. I have faith in you, so that's okay. Installing Rust, you already, or everybody installed Rust at some point, I think. So it's pretty straightforward. Like I said, if you go with the extensor, you need to do some special steps for the tooling for the extensor. But aside from that, I think that you will manage. Also, the books, just good documentation, read through them, follow them. It should work out basically. And at least for these pieces, they do have a metrics. Is it metrics? I think it's metrics. They have a metrics channel where you can ask questions and they help you. And it's I'm not paid by ESP, curiously, but they're really doing a great job. Yeah. So if you have done all that, then one of the things that the training book will tell you, and I think it's pretty great, is that you can pimp your cargo. So one of the things I really like about Rust is that you can extend cargo, and you can, for example, here extend cargo that you do a flashing. So you do not just run it, but you also flash it on the microcontroller and immediately run it. So it's just one command, and then it takes all your code, runs it on the microcontroller, boots it up, and you can test it. So and it connects to the logs and everything, and that's really nice. One thing that they also will tell you is please do not set up your own projects. I'm bad at reading advice, so I did it anyway. And it usually doesn't work. It's really you have to have the correct combination of Rust crates, because the official symbols might match, but still some detail will not match, and then it will not work. So you really should, like for the other project, should rather generate the project and have the correct combination of crates that are proved to have worked in the past, and yeah, shoot yourself not in the foot trying to kind of figure out why something doesn't work. At times it just compiles and just doesn't work. So that's even the worst one. If you, I mean, you can use the ESP flash. That works great. At times, you might, for example, drive to your favorite Eurorust or wherever you just usually go, and you do not always want to carry all your microcontrollers with you, and they are kind of delicate, so you don't want to kind of damage them. There are simulations for that. So there's this company or product, I don't know, Wokwi. They kind of provide you with an ESP32 emulation. Yeah, I think the correct word is simulation. Sorry, and that works surprisingly well. I mean, I kind of tried it out. The dogs are okay-ish, but you can ask them questions actually, so they answer on your questions quite okay. And for the most part, it works. I just encountered one or two bugs, and then it was just easier than doing the microcontrolling. Also didn't travel that much at that time, so wasn't a thing where I really needed the simulator. But might not be a bad thing to have that. So if you kind of are curious, I would just check that out. Also, that probably then means, for example, if you do not want to buy an ESP32H, I think they are a little bit more costly, at least a few euros, maybe. Then you can try the simulator first, see, hey, is it maybe okay? Does it sound right, what it does? And then you can still figure it out. So can recommend that. Yeah. And that's basically where I'm ending up with the scenario where I originally tried to use Rust with. So my idea was I need a microcontroller because I want to have my kind of notes that I usually have in Google Keep, and I do not want to have to reach into another device. I want to have an e-paper which displays all the to-dos that are still open somewhere in my apartment, for example. And of course, you can do that with Raspberry, for example, but that would mean that Raspberry would have powered on every time, or at least you would have to start it at certain times. And I would thought, well, I will do that with a microcontroller, and perhaps even have a button. So, yeah. And the red thingy, of course, means that I still don't have a button on that. I do have a prototype where I can kind of load tasks and kind of displays it, the whole thing on the e-paper. Like said here, it's still not doing it at 6 or something. It just it never got beyond the prototype stage, basically. Where did my slide go? Here. Okay. So just to give you a kind of thingy how that looks usually. So what you have here is, for example, the microcontroller, inverted, of course. Here you connect the pins. Here you have the USB. So that's power, basically, and control, where I then flash the program. And I mean, that's nothing new for people who have already done it, but here you have the connecting. Then the cables go all the way to the driver. So that's the driver board, basically, who drives or who kind of does the communication with the e-paper. So kind of does the protocol. Yeah, you kind of figure out what the protocol is, but there are libraries for that. And I do not have a great experience with a lot of manufacturers. I do have some of the e-papers from Waveshare, and they are pretty okay. The Rust support is kind of good. And yeah, that's just what I tried out and can recommend. So if you want to give it a try, at least I think there's nothing standing against WaveShare e-papers, I think. Then you kind of have the connecting here, and then you have the display connector. And then, for example, if you do that, then you have the e-paper, and then you say hello Rust, and then you kind of moved all the data to there. Then you can already, I mean, these are pixels basically. Then you can display anything that you want on that device. Yeah, that's basically this is not bragging rights or anything, but it's at least yeah, how you can expect that to go. And you still then have to do additional tasks. I mean, that's not like having a chassis like here. We still have to kind of do housing and kind of trying to solve all that. So be aware that the real work goes beyond just programming the device, the microcontroller. Now, if we come to a few challenges, I cut it down a little bit. I mean, you already can imagine, since we do not have that much RAM, then we only have a limited stack. Also, if you, for example, try to allocate something on the stack which doesn't fit on the stack, that will just mean that your device is restarting. So it's not like it will tell you, hey, you used too much. No, it just restarts. And you have a few of these idiosyncrasies where you, as I don't know, an abstract programmer would expect your OS to kind of tell you, hey, you are doing something wrong. No, it will not tell you anything wrong. It will just go. It will not go up in flames probably, but it will do something, and you will not at first figure out why is it doing that. And then you really need to look at your code and see and try to figure out what it's doing, which is also kind of problematic because in Rust, there's also a tendency to kind of abstract stuff a little bit too much, in my opinion. And at times it really means that you have to go into the Rust code because it's so generic and so blah. And you kind of have to figure out which kind of memory it is allocating implicitly where, and where are the boxes and where not, and where is it using the stack and what. So I mean, it's doable, but it's a little bit yeah, it's a little bit cumbersome at times. Let's put it that way. One thing that you really should look out for, at least if you want to do development, is that the protocol for talking to the microcontroller over USB is using usually the UART. And you really need to be careful to choose a chip where you can use UART and you can use other pins also. So if the other pins, or if the UART pins are used to, for example, drive LEDs, and you want to drive LEDs, then you cannot program your thingy anymore. So you really have to kind of be mindful about, okay, I need to have, for example, a dev kit with distinct UART pins, and then I need also some other pins which can, for example, drive LEDs. And there's just a kind of little bit consideration with where you kind of need to think about that before buying, hopefully. Or you buy just one or two and try to figure it out. Then, I mean, you have a whole lot of kind of protocols that you can use. These are usually wire protocols. So here you have something for getting LEDs to kind of light up and work. Here is more general faster communication. To see is kind of not great, but not bad, I would say. And one wire I don't really like, but it's kind of yeah, for really simple stuff it may be okay. So still, we will not do the live coding here. I would just try to give you some kind of idea how it might look like, and you all, I mean, that's nothing new. We have a gazillion users. You all are familiar with that. Then there's, for example, if you use IDF, then there's some patches that you need to be done. So you know this, you do it, all that's pretty deep in the system. You do a logger initialization. That's also not so interesting. Here it gets interesting because if you, for example, I have a display. If you allocate the display on the stack, it will blow your stack probably. So you are not allowed to do that on the stack, but you need to box that whole thing. So all these things you kind of need to learn. And that's where it's a little bit cumbersome, because you kind of need to figure out, okay, is it doing it on the implicitly on the box, using box inside of the display? Some libraries are, some aren't, and kind of you need to dig into the source code at times, and that's the annoying part. Aside from that, if you have done anything with C, then probably that's pretty nice, because you can just define, for example, that the GPIO 14 I want to use as an output pin, and use into, and it does all the crap for you. Doing that in C, can remember that it's a little bit more cumbersome to kind of get it to be an output pin. And the rest's pretty simple, just straight up Rust code. I mean, there's what you would do anywhere. You just really need to be mindful. You need to configure it with the correct baud rate, the correct config for SPI communication. There's just a lot of you need to get right. If you get it wrong, it's just not working. It might not give you any hints why it's not working. It's just not working, period. For drivers, yeah, what I built here is just an example where you, for example, depending on whether you have an anode or a cathode LED, you need to kind of reverse the thingies, so the values. Yeah, that's just basic interaction with the pins on this whole thing. I mean, it's a little bit interesting here if you come to the clock cycle. But basically most of that it's kind of documented, and the rest, if it's not documented, you kind of have to figure it out and kind of try to figure which kind of parameters your device has and how you need to interact with that. But yeah, I mean, that's probably what's kind of normal, or what you would expect for embedded programming. So
maybe I just repeat the question. So where does the logging go?
Yeah, the logging. I haven't run an example with no STD. I can just tell that the STD variant via IDF is streaming the logging over UART to your console. So that's pretty nice. I do not know whether this is working with no STD.
So yeah, this is also working for no STD.
Oh, that's
Same
nice.
thing, I think.
That's pretty nice. So yeah, but that's basically most of my rambling, I think. And now you already started it. Questions, feedback, now's the time.
Thank you, Andreas, for presentation. I have a question related to your pain with C code and embedded Git. Any existing tools to simplify this task? Have you seen, or it's not exist?
I mean, with regards to interfacing Rust with C, you mean? There are some tools out there where they use the symbols and generate the Rust code for that, or they try. But the result, I mean, I think the problem is there are no standards in C. Everybody does everything basically. So I think I found some tools that do something, generate some headers, but the manual cleanup afterwards is probably as bad as writing it from hand. So I don't know. It didn't help me. Also, for the most part, it's the problem of getting all the paths right and the paths in a format or times split even, so that the bindings kind of like that. At times, if you have I had a lot of fun with Ubuntu, because with Debian packages, it's at times different what the original maintainer would have done. So that's one of the reasons why nowadays switch to Fedora, because it's less fucked up, and it's probably easier to do the development on Fedora, where everything is not as mangled as it is in Debian, for example. But at least that's my hope, because with Ubuntu, I had a lot of problems on the system side, because it just diverges way too much from what the upstream usually uses for headers and how they are packaged, how they are structured, and so forth.
You're talking only about operational system interaction. What about nested legacy code written in C, for example? And what is your recommendation which step we should do to migrate from C to Rust? Initial idea is to embed it or wrap or extend with Rust.
Yeah, I think it does really depend on the ownership model that you have in the C code. I mean, Rust has very strict rules about ownership. So usually C code has everything. I mean, there are a lot of libraries who just do it somehow, and you have to figure out what the ownership model basically is. So my first instinct probably would be not to try to get a large C code base, for example, to Rust, but to kind of interface it and kind of try to make it work. But I mean, that probably also just works to a certain extent, or to the extent where you have to kind of think about, okay, how much state is living in the C code, how much state is actually, do I need to transfer objects? Is it okay to copy them? Do I need to reference them? I think there's a gazillion kind of stuff that you need to take into account. So I don't think there's one fits all advice for that. My experience, at least.
Thanks for the talk. One quick comment on Embassy. I think you've mostly presented it as Tokyo, as a Tokyo alternative, which usually Tokyo sits on top of the operating system, right? And Embassy aims to be the operating system, and hence tries to replace, for example, free authors. Why? And now you said why would you do async on an embedded controller? And they claim instead of doing what FreeRTOS does, which has threads, and then it has an interrupt controller to preempt these threads and then switch between threads back and forth, they use the async model, which is basically coroutines, which allows them to switch between different tasks. And hence, I mean, it's a different model. It's like a cooperative scheduling, right? Because the coroutine has to willingly schedule back to the operating system. But if you do that regularly, I've heard claims that they're more efficient. They have like less overhead than what FreeRTOS does. It's basically a smaller hammer, and in certain scenarios, it actually works quite well.
I can believe that. I still don't know whether I think the embedded space is quite big. So in the stuff that I usually do, I probably would not want to use any async stuff. I really want to kind of have the control of, hey, that memory is just allocated now here, and if I need to be cautious about memory, I just deallocate it and move it, I don't know, somewhere else or whatnot. So for me, it would be more mental strain probably also. But I think I'm not doing that day to day. So perhaps if I would be more doing that more often and more familiar, maybe that would be fine. It's just for the guy who does it every once in a while. It's kind of like no, I don't like that complexity.
Yeah, I think it also depends what you're doing, right, with your microcontroller. As for example, the example you've just shown with the display, right? Like you're basically fully in control what's happening when. But for example, if you have, I don't know, an running MQTT connection or like a stream to a music system or an audio system, where you basically in regular intervals need to react to like inputs, because otherwise the client might think you're dead and like breaks the connection, and then you have like very quickly like multiple things going on at the same time. Then it gets like really nasty about like if you don't have threading or like any kind of like multi-task scheduling going on, it's like really hairy to do that.
Yeah. On the other hand, the question always is maybe you even would like to have more than one microcontroller in that scenario. One for handling the QT and stuff, and one for doing something else. But yeah, I get what you mean.
Any more questions?
Some time ago, I played with STM32, and when I got off the very simple blinking the LEDs path, things became very difficult, and howls became very, shall we say, interesting and difficult to initialize. Particularly initializing on STM32 proved painful. I haven't looked into this area for about 2 or 3 years. Have things changed in terms of documentation and support much in your experience and of the experience of the audience?
For me, I only have experience with ESP32. So, yes, no. So the documentation is good. I mean, I'm one of the guys who is really kind of happy if there's documentation at all. I mean, we all kind of are probably rather coding than documenting usually. So that's, from that perspective, pretty great. But it also kind of depends on how much value there is, I think. So I know that the Express guys have dedicated developers assigned for Rust, for example. So they can probably do some more progress than if you have some open source guy who does it in his 9th hour of work or something. So I really can't speak to other devices, really. And you need kind of to really read a lot of documentation, because the not all values are kind of easily accessible. That's what I found, at least. But on the other hand, at least for me, if you do not have a deadline and you kind of have all the time in the world, so that's okay, because I can didn't find it today. Okay, I'll search tomorrow. Who cares? If I would have a deadline behind that, then it would probably get a little bit more annoying to search for parameters and find why certain stuff doesn't work. But probably not answering the question.